Additional maths, algebra section, changing the subject of a formula.
Changing the subject of a formula. Given an equation, it's often useful to rearrange it so that a particular variable or letter is made the subject. That means the letter is on its own on the left-hand side of the equation, and all the other terms are on the other side of the equation. To achieve this, we use the same methods we use when solving an ordinary equation. As long as we do the same thing to each side, the equation remains true. Let's look at an example. Make S the subject of v squared equals u squared plus 2as. Now we start with v squared equals u squared plus 2as, and we swap the sides. This puts S on the left-hand side. That gives us u squared plus 2as equals v squared. Now if we subtract u squared, that means the other terms are now on the other side. And we have 2as equals v squared minus u squared. Now if we divide by 2a, this will leave s on its own, and we'll have s equals v squared minus u squared all over 2a, and that's our solution. Let's look at another example. Make u the subject of v squared equals u squared plus 2as. So we start with v squared equals u squared plus 2as, and the first thing we do is swap the sides. This puts u squared on the left-hand side. This gives us u squared plus 2as is equal to v squared. Now if we subtract 2as from both sides, that will leave just u squared on its own and all the other terms on the right-hand side. This gives us u squared equals v squared minus 2as. Now we've got u squared and we want u, so we take the square root of each side, and this leaves us with u equals plus or minus the square root of v squared minus 2as. Let's have a look at a third example. Make r the subject of a equals pi r squared, where r is a radius. Now to solve this, we start with a equals pi r squared. We swap the sides. This puts the term with r on the left-hand side. So we have pi r squared equals a, and if we divide by pi, we get r squared equals a over pi, and if we take the square root, we get r is equal to the square root of a over pi. Now we only need to take the positive square root, as r is a length and therefore cannot be negative. Now there follows an exercise of equations. After the equation in square brackets there's a letter. That letter should be made the subject of the formula. Have a go at these first by yourself, and then I will go through the solutions. Okay, let's have a go and see how these are done. In the first equation, we've got v equals 1/3 r cubed h, and we're asked to make r the subject. Well, to get r onto the left-hand side, we'll start by swapping sides. This gives us 1/3 r cubed h equals v. Let's get rid of the fraction by multiplying by 3, so r cubed h equals 3v. Now we don't want the h on the left-hand side, so we'll divide by h, and that gives r cubed equals 3v over h. And we want r on its own, so we'll take the cube root of both sides. R equals the cube root of 3v over h, and that's our solution. In question B, we have E equals mc squared, and we're asked to make m the subject. Well, to get m on the left-hand side, we'll swap the sides. That gives us mc squared equals E, and to get m on its own, we'll divide by c squared. So m equals E over c squared. In question C, we have E equals mc squared, and we're asked this time to make c the subject. So the first thing we'll do is swap the sides to get c onto the left-hand side, and that gives us mc squared equals E. Now we'll divide by m, so c squared equals e over m, and then we'll take the square root. So we have c equals the square root of e over m. Strictly speaking, it should be plus or minus the square root of e over m, but the equation E equals mc squared is a very famous equation by Einstein, the relationship between mass and energy, and c is the speed of light, which is always positive. In question D, we're asked to make A the subject of V equals U plus AT. So as usual, we swap sides. U plus AT equals V. Subtract U from both sides, and that gives us AT equals V minus U. And to get A on its own, we'll divide by T. So A equals V minus U all over T. Now in question E, we have A equals B plus C into T, and we're asked to make B the subject. So swap both sides, B plus C into T equals A, expand the brackets, BT plus CT equals A, and subtract CT, and that gives us BT equals A minus CT. Now we want B on its own, so let's divide by T. B equals A minus CT all over T. In question F, we have xy minus 2 equals x, and we're asked to make y the subject. Well, y is already on the left-hand side, so let's add 2 to both sides. That gives us xy equals x plus 2, and to get y on its own, let's divide all the way through by x, so y equals x plus 2 over x. In question G, we have xy minus 2 equals x, and this time we want to make x the subject. So if we add 2 to both sides, we end up with xy equals x plus 2. Now let's subtract x, and we have xy minus x equals 2. If we factorize the left-hand side, take x out of the bracket, we get x into y minus 1 equals 2, and we divide by y minus 1. So we're left with x equals 2 over y minus 1. Now in question H, we're asked to make L the subject of t equals 2 pi times the square root of g over L. Well, the first thing to do is get rid of the square root sign. So square both sides, and that gives us t squared equals 4 pi squared times g over L. Now if we multiply both sides by L, on the left-hand side we have t squared L, and on the right-hand side the L's cancel out to leave 4 pi squared g. Finally, if we divide by t squared, we end up with L equals 4 pi squared g over t squared. In question I, we have a squared equals b squared plus c squared, and we're asked to make b the subject. So to get b on the left-hand side, we'll swap the sides, and that gives us b squared plus c squared equals a squared. Now if we subtract c squared, we'll end up with b squared on its own, so b squared equals a squared minus c squared. But we want b on the left-hand side, not b squared, so we'll take the square root of both sides, and we end up with b equals plus or minus the square root of a squared minus c squared. For question J, we want to make n the subject of theta equals 180 times n minus 2 over n. Well, to get rid of the fractions, we'll start by multiplying by n. And that gives us theta n equals 180 into n minus 2. Well, now let's get rid of the brackets. So we have theta n equals 180n minus 360. Now, if we swap the sides, that gives us 180n minus 360 equals theta n. And if we add 360 to both sides, that gives 180n equals theta n plus 360 degrees. Now we can subtract theta n from both sides, and that gives us 180n minus theta n equals 360, which if we factorise the left-hand side, gives 180 minus theta all times n equals 360, and we can divide by 180 minus theta. So that gives us n is equal to 360 over 180 minus theta. Now in part K we're asked to make b the subject of 1 over a equals 1 over b plus 1. Well, let's first get rid of the fractions by multiplying all the way through by ab. This gives us ab over a equals ab over b plus ab. Now, the ab over a cancels to just leave b, and the b's cancel in ab over b to leave just a. So we now have b equals a plus ab. Now we want to make b the subject, so we want to get all the b's onto the left-hand side. So subtract ab, and we end up with b minus ab equals a. Now we can factorise the left-hand side. B is common, so we have b into 1 minus a equals a, and we can divide by 1 minus a to leave b equals a over 1 minus a. Now in question L, we have c equals 2 pi r plus 2l, and we're asked to make r the subject. So to get r on the left-hand side, swap the sides. 2 pi r plus 2l equals c. Subtract the 2l, 2 pi r equals c minus 2l, and divide by 2 pi. And that leaves r on its own, so r equals c minus 2l all over 2 pi. In question M, we're asked to make a the subject of s equals ut plus a half at squared. So let's swap the sides. Ut plus a half at squared equals s. Let's get rid of the fractions by multiplying by 2. 2ut plus at squared equals 2s. Subtract the 2ut. At squared equals 2s minus 2ut. Divide all the way through by t squared, and we're left with a equals 2s minus 2ut all over at squared. And finally, in question N, we're given r over r plus 1 equals a, and we are asked to make r the subject. So let's get rid of the fractions first by multiplying by r plus 1. And that gives us r equals a into r plus 1. Now, let's expand the brackets, so r equals ar plus a. Subtract ar from both sides, so r minus ar equals a. Factorise. R is a common term on the left-hand side, so r into 1 minus a equals a, and finally we can divide by 1 minus a. So we're left with r equals a over 1 minus a.